Welcome to the 6.7 podcast. This is on falling and air resistance. The main idea is the air resistance the air resistance force an object experiences depends on the object's speed and area. We're going to get a lot into terminal speed, parachuting, skydiving, and we'll try to put everything together that we've learned this chapter. So we already know this, that a feather and a coin fall with equal accelerations in a vacuum, but very unequally in the presence of air. And the coin we're going to fall quicker, while the feather will flutter to the ground. And this is due to the air resistance on each of them. The air resistance on the feather is a lot larger than the air resistance on the coin. So you experience the force of air resistance when you stick your hand out of the window of a moving car. And I want you to try this the next time you're out in a car and you have the window rolled down. So if you put the car moves faster, the force on your hand increases. So you can just put your hand out of the car and step on the accelerator, and you're going to feel your hand being pushed back. So now what you can do is hold out a physics book or a larger object and keeping the speed the same. You're going to see the air resistance force is much larger than on your hand at the same speed. So move faster, the force on your hand increases, and if the surface area gets bigger, the force on your hand is going to get bigger. Here's a great way of doing it: is you could take your hand and hold it out flat like this, or you can then turn it sideways so that it slices through the air and you can see it. So those are the two things that are area resistance forces dependent on. It's dependent on the speed of the object that's moving through the air, and also the frontal area that's trying to push through the air. Something more, and frontal area we mean by how really you can think of how aerodynamic is. A hand lying flat like that is far more aerodynamic than a hand held flat out like that. And both these things are directly proportional to the air resistance force. Okay, terminal speed is the speed at which the acceleration of a falling object is zero because the friction balances the weight. And that friction is going to depend on the speed of the skydiver and the weight of it. Terminal velocity is just another word what we use when we talk about terminal speed along with the direction of the motion. For the purposes of this chapter and this section, don't worry about the difference between terminal speed and terminal velocity. Don't get hung up on the difference between them. One's a vector and one's a scalar. The reason why is we're going to assume for the most part that the direction is known. In most cases, the direction is going to be downward because we're going to be talking about something skydiving or falling through the air. So let's look at a body accelerating in free fall. The body is released, and you can see that there's a weight pulling the body down right here. And then as the body accelerates, it starts to get faster, and a drag force, this is air resistance, starts to build. Now if you look, that force is smaller than that force. Then as the object gets faster and faster, the drag force increases, because remember, it's dependent on the speed of the object, until the drag force and the weight are equal. And at that point, the body is at terminal velocity. So the drag force and the weight have to be equal for there to be no net force on the object. And then the object won't accelerate any faster. It'll be at its terminal velocity. So here we're talking about zero acceleration, and we're not talking about zero velocity. In other words, an object that has zero acceleration on it is still moving. It's neither speeding up nor slowing down, but it still has a velocity. So once again, to reiterate that, skydivers reach their terminal speed when air resistance equals their weight. A falling feather or piece of paper reaches its terminal speed quite quickly, and the reason why is it has a very large surface area and very small weight. So the air resistance equals the weight very quickly as it falls. A coin has a very small area compared to its weight, so it's going to have a much faster terminal speed. You can often think that things that are denser, because those things will have a very small area and a very large weight, will have a much higher terminal speed. Terminal speed for a skydiver is about 150 to 200 kilometers per hour. That's very fast. And of course, this depends on the weight pulling them down and the orientation of the body. A heavier person will attain a greater terminal speed than a lighter person, and when the body area is spread out, its surface area is increased, their terminal speed will be slower. This guy right here is trying to make himself very streamlined, so his terminal speed is going to be vastly increased. Here's a squirrel who's trying to increase his air resistance by spreading himself out, by changing his body orientation so that he takes up a lot of he has a large frontal area, and this is going to slow down his speed of fall. So terminal speed can be controlled by variations in body orientation. So if you have a heavy skydiver and a light skydiver going on at the same time, the heavier person spreads out like a flying squirrel. They can match the speed of the lighter person who might want to fall head first or feet first, so they get more speed. And the parachute will greatly greatly increase air resistance, and it'll slow people down to 15 to 25 kilometers per hour, as opposed to 150 to 200 kilometers per hour, which is a human terminal speed without a parachute. And that 15 to 25 kilometers per hour is slow enough to land. So let's look at what happens. We have that ball that was falling, and the parachute's released, and all of a sudden we have a large drag force here, much larger than the weight. So what happens is that the object, the velocity decreases, it starts to decelerate. As it decelerates, speed goes down, the drag force decreases. So if velocity decreases, drag force decreases. And then eventually what happens is the body will decelerate until the drag force equals the weight, and then you reach a second terminal velocity with the parachute. We'll look at this more closely in one of the worksheets we're going to do. At low speeds, air resistance is often negligible, but at high speeds it could make a difference. I would say for a sprinter, air resistance could be a factor, but for a distance runner, it probably doesn't make that much difference. Now, the weight of an object can make a difference in how far you drop it, because how far you drop it will determine the speed. So if you drop a baseball and a tennis ball from a really short distance, they're going to hit the ground at just about the same time. But if you drop them from a much higher spot, you're going to notice that the heavier baseball strikes the ground. You can do this with a golf ball and a ping pong ball. Here's a golf ball and a foam ball, which is pretty close to a ping pong ball, and you can see the golf ball, which is right here, is going to hit the ground before the foam ball does, because it has a much higher terminal speed than the foam ball. Here's a little trick you can do, and I'll try to do this, make sure I do this in class at least once, where you take a piece of paper. You're going to need a piece of paper and a book, and you can pause this and read the instructions to see how it works. There's 3 things to do here. So which experiences greater air resistance, falling piece of paper or falling elephant? The elephant does, because the elephant has a greater frontal area. Which of them pushes more, reaches terminal velocity first? The paper will reach terminal velocity first, but the elephant has a greater air resistance. So a heavy person and a light person open their parachutes together at the same altitude, and each wears the same size parachute. Who will hit the ground first? The heavier person will, because they have they're going to continue to accelerate longer because they have a greater terminal speed to reach, because their weight is larger. What factors determine the air resistance? Force on an object. The air resistance depends on an the air resistance, force, and object experience depends on the object's speed and area. And here's a movie poster from a Charlie Sheen, believe it or not, Charlie Sheen movie that was called Terminal Velocity, which was about skydiving.